All right, here we go. Next lesson. We are trying to solve logarithmic and exponential equations. The key to solving these is to know this right here. Now, we've had this before. It's converting from exponential to log or log to exponential. And chances are, if you can't solve the problem the way it's written, this is in log form, then it can be solved in the other form, which is exponential. Now remember, around the world, so 5 to the power of 2 is going to equal the quantity 4x minus 7. And 5 to the 2 is 25. And now this is just a basic two-step equation. I'm going to add 7 to both sides. I'm going to switch sides here. 25 plus 7 is 32. And 32 divided by 4 is 8. Now, the other day I mentioned you can never take the log or natural log, or no matter what base it is. You can't take the log of a negative or 0. So if this causes you to get a negative or 0 in here, then it's not a solution. The 4 times 2 is 32 minus 7 is not negative, it's not 0, so this answer is perfect. Now this one is a log, but I can't type this in my calculator the way it's written because that's a base 8 log, and this button right here is base 10, common log base 10. So I can't type that in. So I don't know what to do in log form. I'm going to write it in exponential, so it'll be x, or 8 to the x minus 1 equals 16. And this is similar to problems we did on a previous assignment, where I want to write the bases as the same number. 8 can be written as 2 to the third, and 16 can be written as 2 to the fourth. Well, the rule of exponents is to multiply these exponents, so 3x minus 3 equals 16. I don't know why I just did that. Yes, it equals 16, but I want the bases the same, so I'm going to leave that as a base of 2 to the fourth. Now, because these bases are the same, then the exponents have to be the same. So I set the exponents equal, and I solve. So x equals 7 over 3. Now there's no x over here where the log is. I'm not going to take the log of a negative or 0. This over here can be negative or 0. That can't. All right. Now this one is an exponential equation, but I can't, just like this is exponential after I change the form, but I can't write with the same base. So I have to go to plan B, and plan B is to write it in the other form. The other form would be log, so it would be log base 8 of 25 equals x plus 2. Well, we just said the last problem, you can't write or use the calculator with a base other than 10 or e until now. We can use this right here, which is called the change of base formula. So this is change of base. And if I use this formula, I can write any base I want. So this can be written with a base of 2, a base of 7, a base of 12, but it would make sense to use a base of 10 because that can be done on a calculator. So the key here, I want you to notice the base here is on the bottom. So this would be log of 25. Notice I'm using a base of 10. Anytime it's not written, it's understood to be a base of 10. Now I can type that in my calculator. Now to solve for x, I'm going to have to subtract 2. So I type this in my calculator, and now I can do the base, even though this is base 8, I can change it to base 10. I'm going to use the fraction button. It'll be log of 25 divided by log of 8. And minus 2. I type that in, I get negative 0.452. And because this isn't a log problem, I can put any number in there, because if you remember when we did exponential growth and decay, the domain was all real numbers. It doesn't matter what you plug in there, but it does here. You can't have a negative in there. Next problem. This is very, very similar to what we learned earlier today and on a previous lesson. Again, if your bases are the same, your exponents must be the same. Well, if this log and the base is the same as this log and the base, then I can just set these two quantities equal to each other. Well, those bases are the same, so I can do this. And of course, I know you remember a problem like this is quadratic. In quadratics, we want to get equal to 0. So I'm going to add the 2x to both sides. I'm going to subtract the 4. And the first method I'm always going to try and do is see if it can be factored. Remember, we took a times c, so that's negative 15, and then b goes on the bottom. Two numbers that multiply to give you the top, add to give you the bottom. 5 and negative 3, so x plus 5, x minus 3. Set your factors equal to 0 and solve, so x equals negative 5 and x equals 3. But we always have to check when we have a log problem. Do I take the log of a negative? Well, negative 5 squared is 25 minus 11 is not negative. That's 14. 5 minus 2 times negative 5, that would be minus a negative 10, which becomes plus 4 plus 10 is 14. That works. But 3 squared minus 11 is a negative, and you cannot take the log of a negative value. So there's only one solution to this problem. Now remember, ln has a base of e. We've done that before. And I can't type that in my calculator, so I'm going to go around the world. E to the 5th power equals 2x plus 1. Okay, forget about this side for a second. If you want to solve for x, I want to subtract the 1, divide by 2. So I'm going to subtract the 1. Now the 1 is being subtracted from the e to the 5th, not the 5, the e to the 5th. And then I divide by 2. So it'd be e to the 5th minus 1 over 2, which can be done in the calculator. And again, I'm going to use my fraction. I'll show you how you can do this without that fraction button. So it would be e, remember that's second ln, 5, get out of the exponent, minus 1, that's the top of my fraction, the bottom is just a 2, and then I get 73.707. Okay, because we're rounding to the third place. I know the directions didn't say that, but we did that the other day. All right, now how can you do this without, if you didn't have that fraction? Really simple. Put the top in parentheses. And it'll do the same thing. So parentheses, second ln, 5, get out of there, minus 1, close the parentheses. Now I'm dividing the whole numerator by 2 and not just part of it. Get the same answer. All right, last one. This is an exponential function. Exponential growth, if you remember, because that's 2.7, which is larger than 1. It's an exponential function here. But I can't type this in my calculator, so I'm going to write it in log form. But because I have a base of e, I use natural log, because natural log has a base of e. The exponent always goes on the other side of the equal sign, therefore the 64 goes here. Well, I can type in natural log of 64. I might as well go ahead and divide by 2, so I only have to type it in one time. Again, you don't have to use the fraction button. You can do natural log of 64, close your parentheses, now divide that by 2, and you get 2.079. I forgot to check something on this previous problem. Remember, we can't take the log of a negative or 0, but 2 times 73 plus 1 is not going to be 0 or negative. This original problem is not a log. An exponential has a domain of all real numbers. It doesn't matter what you plug in there. It's going to work. So this is the correct answer. All right, hope you learned something. Your homework is the right side of the paper.